This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI Podcast. My name is Peter Seeberg and my guest today is Bryan DeBois. He is Director of Industrial AI at RoviSys. Bryan and I are going to talk about autonomous AI. Hello, Bryan.
Hi, Peter.
Bryan, please introduce yourself to our Industrial AI Podcast listeners.
Yeah, so Bryan DeBois, I am the Director of Industrial AI, as Peter mentioned, at RoviSys. Been with RoviSys now for over 23 years and been in this role since 2019. I started out with a computer science background from the University of Akron and started doing development for RoviSys. RoviSys has been around since 1989. They are one of the largest independent system integrators in the world, and we are focused almost exclusively on industrial and manufacturing customers. So when I started with them in 2000, I started writing code that would leverage all of the data coming from the plant floor. So if any of your listeners are familiar with the ISA 95 stack, that's level 3. So I would consume that data, historians, MES, custom software. I mean, we didn't call them data warehouses back then, but data warehousing, all of, leveraging all of that operational technology or OT data coming from the plant floor. Now in this industrial AI role, we're doing, the same kind of thing and leveraging that OT data, but now we're applying AI and particularly autonomous AI approaches to that data.
Wow, that's a great introduction, already including your company as well. 23 years is the main thing I picked up. That's a very long time. I mean, very long time in a positive sense for you, and because I was going to ask you, since when does RoviSys exist? And if you are there 23 years and you said 89, that's 11 plus 23, that's over 44 years. So if we then later on come to the autonomous AI bit, it just gives the feeling that your company has had a very, let's say, deep, long basis for doing the things that I assume you're capable of doing today.
Yeah, exactly. And, RoviSys is a great company. When I started there, we were less than 100 people, and now we're 1,400 engineers around the globe with 14 locations. So it's been great to watch that growth. But people tend to come to RoviSys and they tend to stay for a long, long time.
Sounds good. We'll talk a bit about more details like the engineers and where you're based at the very end. Then let's go a little bit more into the details of the capabilities, let's say, of RoviSys. In the Industrial AI podcast, we typically talk about, I think, what you do, also process automation, discrete manufacturing, 2 other 3 things. But there's a list of other things that I saw on your website. Maybe you just want to quickly mention them just so we have a feeling for the wideness, the variety of activities that you apply.
For sure. Yeah. And we have about 14 different industries that we service. So that's everything from life science, oil and gas, chemicals, consumer packaged goods. The list goes on, food and beverage. And then we do a lot of work in data centers, particularly in Europe. So that's building automation around data centers. So the common thread there, so it sounds like we're really kind of scatterbrained and we've got our, we're spread thin, but the reality of it is the common thread there, as many of your listeners are aware, is, the tools that we leverage in the industrial space are the same, right? So we're still going to use PLCs and DCSs. We're still going to use HMIs and SCADAs across all of those different things. And we're still going to use historians. We're still going to use MES in a lot of those spaces. And now we're leveraging AI.
Sure. I was going to suggest that, and maybe we'll get to that later, but when I was closer and as I think we call ourselves like market segment manager, and I was doing the discrete side of, let's say, manufacturing, and my colleague was doing the process side. So there is, of course, very clear, I mean, still today, and a difference in approach. You just mentioned historian, which is maybe has a different name in the discrete and stuff like that. And in process, there's more like also algorithmic based different approaches, I do believe. But then in the end, maybe through all the automation and then in the end autonomous, I'm interested in learning later on then if those differences still apply or not.
Well, and it's been interesting. We can definitely get to that. But, even in the world of process versus discrete, which I agree. I mean, 20 years ago when I started, those were kind of very distinct kind of categories. Even that's starting to, to meld and get a little gray now. So
that's what I would have assumed almost, yeah. I mean, and now we're talking all of the industrial kind of markers and activities. And then if we start comparing the things that your company, that I've been doing, that we in our podcast do, and then you start comparing it to complete other activities. I think about healthcare, I think about what you do at your local doctors, or you go to retail, and suddenly through data and through data analytics, all of these activities at a higher level, they seem to be somehow coming together, right? Things that you have learned on the basis of data in one market, you can apply in a complete different market segment these days. So let's zoom into industrial AI solutions. What are some of the specific then industrial AI capabilities that you provide to customers?
Sure. I mean, we certainly have done things like, unsupervised learning, which is anomaly detection, as you're probably well aware. And so we're looking at the process. We're saying this is what normal looks like, and it's learning that without any a priori knowledge. And then it learns what abnormal starts to look like. And so it can alert you to that. So that's the unsupervised learning. We've done things there. We've certainly done a lot in supervised learning. So of course, that's when people think about it, machine learning, that's typically what they're thinking of. So you're taking large volumes of very clean, very correlated data, and you're sending it through an ML model, training it on that labeled data, and it's going to predict a value. But effectively, that's all it can do with supervised learning is it can predict a single value. Here's how many days until this particular piece of equipment may fail. Here's what the final quality of this particular batch might be. It's going to predict a value. But that third category is the one that we're really excited about, and the one that we'll probably focus on today, and that's autonomous AI. At the heart of autonomous AI is deep reinforcement learning. And what that does is effectively what a lot of our customers think AI can do when I first sit down with them. And that's that it can make a decision. So it can look at the current state of the line and say, based on the current state of what I'm seeing, here's the next best thing that you can do. Here's the next action that you can take. And that's such a powerful thing, particularly in that industrial space.
Right. And before we continue with autonomous, as you mentioned, unsupervised, supervised, there was a chart I shared with you from Andrew Wang. Not sure you looked at it. It's not important if you didn't. Or anyway, we can put the link to his presentation, which he did in Stanford, I think a month ago, maybe. Was a wonderful presentation. I thought my question is going to be if you have a similar view on what he was showing as the value from AI technologies today in 3 years. And he was clearly, and he had these three plus then generative, which is what it was all about. But we'll come to that later as well. But he was showing like the biggest huge bubble on supervised today and also in the future. And he says, so unsupervised is a lot smaller. And then what we come to in a moment, and is the basis for autonomous, I believe he sees very small. So how do you, to start with, do you have a similar experience? I mean, that doesn't have to be, but between first supervised and unsupervised, do you see that similar to him, or is that more equally within the activities you do?
So, and I really appreciated you sending over that presentation. I agree. It's fascinating. And I think all your listeners could get a lot out of it. I hesitate to contradict what Andrew says about anything, him being the expert in this field. However, I am going to go ahead and be bold and contradict him on that. I like you said, supervised learning was huge. Generative AI was a smaller but still large circle. And then in the very corner, you had a tiny little dot that represented the impact of reinforcement learning, which would include, autonomous AI. I think my take on it is this. I think that he has a little bit of, I guess it would maybe be selection bias because of the areas that he's focused on and has been focused on for his career. And that's fine. But I'm focused in this industrial space. And I can tell you that the problems that we try to solve in the industrial space, they're operational types of problems. So they require not just the recognition that there's a problem, but they also require the expertise to be able to solve that problem. And so even in the examples that he used, I was like, oh, you're so close there, Andrew. So he used this example of computer vision and a quality inspection for a pizza company. So how much cheese, is it evenly distributed? Is there enough cheese on the pizzas? And so, a typical computer vision type of problem. So you're going to train it on a bunch of pictures. You're going to label here's the good distribution of cheese. Here's the bad where it's clumped in one corner or something like that. And then you're going to be able to say, okay, so I'm going to flag these pizzas and I'm going to say these ones are wrong and these ones are right. But then what action do you take? And the same thing he showed that, computer vision around the height of wheat, and they can do some things where they can then cut the wheat to different heights. And there were some benefits to that, to the environment and to the health of the plant and things like that. Okay, but then who's going to make the decision on what height to cut that to? That decision making on the plant floor, that's that next step. So we've been able to predict values and show an operator a prediction of a value of what a final quality of a batch is going to be. We've been able to do that for years, and there's definite value there. There's ROI there, but you're also making the assumption that that operator knows what to do to fix that problem. And that's where autonomous AI can step in and say, because one of the aspects of autonomous AI, why it's not just deep reinforcement learning, is an aspect called machine teaching. And that's where we're taking and we're sitting down with the subject matter experts or SMEs that know how to run that line best. And we're extracting from them their expertise. And we're building that into the DRL before it ever even starts its training, before it starts its learning. We're building in those heuristics, those skills. We'll sit down with expert operators and they'll say, well, when the line's running hot, we nudge this value up. Or when the line's running cold, we run this, we turn this knob a little bit to the left. We're capturing all of that. We're building that in through a process called machine teaching to give the deep reinforcement learning a head start, a running start. And then it's able to build its expertise on top of the best knowledge that we have about how to run that line. So now you can put a 1 to 2 year operator, a relatively untrained operator on that line. Yes, they've got the prediction now coming from the system saying, hey, this is what I predict the final quality of this batch is going to be. But then they also have the recommendation coming from the DRL, the autonomous AI, saying, and the way that you fix that is you do this. And that's the part that Andrew, I think, was maybe not thinking about because he doesn't live it every day like I do and my peers do.
Let me come back to that. You're going right through where I want to go as well.
Oh, good. Okay.
I do want to tell you that it's perfectly okay to disagree with Andrew every now and then. I did so very explicitly 2-3 weeks ago when it was about writing a piece of code where I thought, no, I disagree because I think Gen AI today is doing that. But that was a shitstorm in itself. And the other thing I was going to say is that, he has his landing AI. So at some point in time, you or we somewhere may see him in an industrial space as well, I believe, right? So I'm not sure if you have. I mean, you may be at least physically, so to say, closer to where he is or where he's not operating. No, but you are going a little bit fast. So autonomous AI, you mentioned already, deep reinforcement learning. That's the basis of what your autonomous, tell us, what is then for you autonomous AI?
Yeah, so autonomous AI really encapsulates, it's a methodology, so it's not a product. I'm not coming here hawking a product. In fact, RoviSys doesn't even have any products. It's really a methodology or technique, and it grew out of Microsoft Research in particular. There's a gentleman who used to work there who now works very closely with us named Ken Sanderson, and he wrote a book called Designing Autonomous AI. And that book really became the roadmap for this approach. And so we've incorporated that into our offering here at RoviSys. But there's a few key aspects to that. Of course, deep reinforcement learning, you can't do all this without that innovation. And we can talk more about what that is and where that came from. But the second aspect is that machine teaching. And so that's where we build this graph of here's all the skills, techniques, concepts, the choices that are made by your expert operators. And we build that all in to that. The third aspect then, and the part that really shouldn't be overlooked, is incorporation of traditional optimization techniques and things like that. So when we're doing that machine teaching, we can actually incorporate traditional ML. We can incorporate traditional control strategies. We can incorporate rules-based optimization. We can incorporate all of these existing and effective optimization techniques into that machine teaching, and the DRL will actually learn around it. Again, that is an innovative in and of itself. So all three of those kind of encapsulate this approach of autonomous AI.
Right. And when you talk about your expert operators, is what I've been always talking about, like domain experts, right? Mm-hmm. That's what they are, I guess.
Yep.
I mean, and you mentioned somewhere that's on a more, let's say, sociological kind of level, where a huge group of people, that's the same in Europe, I guess, as in the United States, are going into their deserved, pension? Is that how you call it?
Yes.
So they leave the market, and young people come in, and we don't have enough young people. And until now, they would be standing there and hold their hands some on a machine. They would say, "Oh, this machine is okay, that one is not," and the young people have no clue. And would they have? I mean, the theoretical knowledge that they come in, that they have learned, and then they come in and they are, where's my colleague, the 60 plus maybe year old, as he or she is still there, and you try to get that information out of that expert operator into, and that's what you call that machine teaching. I wasn't sure. Machines teaching us, or we teaching the machine. That's what machine teaching is, right?
Yes, that's right. That's right. And I've got a perfect example of that. So I was at a vinyl extruder up in Canada about a month ago, and I'm talking to the plant manager, and we're talking about leveraging autonomous AI on this vinyl extrusion line. And, there was a financial ROI sure there. But honestly, for him, he said, I've got 2 operators that are the best, probably the best in the world at running a vinyl extrusion line. And he said both of them are less than 5 years from retirement. So, and he's like, I have no bench behind them. He's like, I've got a bunch of 1 and 2 year guys. I've got high turnover. None of them want to spend their career becoming experts on how to run this extrusion line. So for him, it becomes an existential problem. He's either going to just live with the fact that he'll never get as much performance out of this line once those guys retire, or he's got to capture that expertise into AI and put it on the line. So, I mean, those are really his only 2 options.
Sounds great. By the way, I was involved here where I'm based in the Munich area on the German market. I wasn't involved in translating a book called Deep Reinforcement Learning. That's from 2 guys, I think, from the United States. And if you know them, Alexander Tsai and Brandon Brown, Introduction to Deep RL. So those listeners that want to know, they can read it, of course, in the original English, which was a very interesting topic in itself. Me as a Dutch guy living in Germany, who was then let's call it the topics lector. So I couldn't, of course, be in charge of the language. So it was translated by a deep learning based neural network kind of application. And I was looking as the person, knowledgeable on the topic to decide if the machine had chosen the right wording. So that's on one side. But then 2-3 questions still on that topic of staying for a second with the deep learning. There was somewhere I did read about, and from your perspective, then maybe as we're making these connections, what is the relationship between Go or chess, let's say AlphaGo on one hand, and manufacturing? Is there?
There is. And I think that actually the application, so as you mentioned, deep reinforcement learning first was applied to games. And so they applied it, DeepMind, which was the Google spinoff that effectively created this algorithm. They created AlphaGo. In fact, there's a documentary called AlphaGo on YouTube for free that you can watch.
Yeah.
Amazing.
1 hour video. Yeah, it's amazing. For those of you that haven't seen it yet, right? Okay.
Yeah, it's great. And then they, so AlphaGo goes on to beat our best grandmasters. And then they do the same thing with AlphaZero in playing chess. And it goes on to beat our best chess grandmasters. Then it goes on to beat our best chess software that had been developed over decades. And this little no-name company comes in and beats all of our best chess software with this approach. So we knew that there was something there. And then it goes on, to beat our best StarCraft players with a program called AlphaStar. So why does it work so well in the world of industrial? And I think that one of the reasons why is that, or there's a couple reasons why. One is that we're able to simulate things well in the world of industrial. So industrial is a pretty constrained type of problem. If you have a process, many of our processes that humans have come up with some of these processes have not changed for 100 years. The process we use to make aluminum and steel, I mean, we've certainly made tweaks and improvements, but the fundamental processes have not really changed that much. And so it's a pretty well-constrained type of thing. The other thing is that part of the role of the control system is to make sure that you only operate within certain parameters or boundaries so that you don't have catastrophic failure of the plant that could lead to, the loss of life or property. So within that, the ability to simulate and then the ability to operate within constraints is actually really perfectly suited for deep reinforcement learning and applying that type of technology.
There's just another small comment I want to make there as well. I must have been like maybe 3-4 years ago at the Hanover Fair we have here in Europe and Germany. And there was a guy called Jan Kautnik from Swiss-based Nasons, and he was on the Festo side. And we were talking, and that was then at that time relatively new to me, reinforcement learning. And he then said these RL, reinforcement learning algorithms, algorithms, they're going to design future production lines. So Festo has this didacto, this education section where people can learn all about production lines. And he said, soon, along the lines of the way you just put it, right? We're going to just give the algorithm the goal of what it is to, let's say, I've got a cup of tea here. So produce teacups, in whatever kind of form, and designed for me the production line that will do that in the best possible way. So you mentioned an example of the extruder. Is there one or two other use cases maybe within the discrete process automation that you can talk about autonomous AI where you have applied it?
Yeah, for sure. So we've got a customer right now who's using autonomous AI for shaping glass bottles. So this is a process that, again, it's a very fast moving process, and they're actually developing a brand new approach to doing this. So I can't get into any of the details about their approach, but because it's so new, they only have two experts, in the world who can actually operate this line at its highest capacity and get good bottles coming out of it. And so we're actually training autonomous AI on that process to get those glass bottle shapes. And that's, when we talked about too, that line between process and discrete, glass is a perfect example of that, because it starts out as more of a process type of thing where you've got this liquid molten glass, and then it turns into discrete. And so right at that point is where we're talking about here, is in shaping those glass bottles. And so we're using autonomous AI there to capture that expertise from their operators and shape those bottles. Another example would be, and the other thing that I love about autonomous AI is we can take, it's a general purpose tool that we can apply to a lot of different problems. So we actually have used it on production scheduling as well. So we have a paint manufacturer that's filling, gallons of paint, and they have two production schedulers, and they have, they build a production schedule, and it takes them typically a couple hours to build a production schedule. They build it out for 8 days out. But the reality of it is by day 1.5, that schedule is not really worth much, because things have changed. Machines have gone offline. Machines have taken longer to run than they were supposed to. Deliveries were late. Latex deliveries were late, whatever. And so now the schedule has to be rebuilt. And every time they do that, those two schedulers have to do it by hand. This is a plant that runs 24/7. They don't always like to wake those schedulers up in the middle of the night. So if a failure happens in the middle of the night, they just kind of operate in a suboptimal mode, and they know that they're doing that, but there's not much they can do until the morning when those schedulers wake up and can build a new production schedule for them. That particular customer, we worked with them to build a simulation. It's called a discrete event simulator. We built a discrete event simulation of the scheduling process, of the line, of the assets. We built in the typical stochasticity or randomness, how long it takes to run a specific asset, because they don't always run in exactly the same amount of time. We built all of that into the simulator, and then we let the autonomous AI, we call it a brain, we let the brain loose on that simulator so that it could learn how to become an expert production scheduler. So another example of applying that, but in a way that maybe people hadn't thought of using it in that way. There's been existing technologies in that space, right? So we have linear programming, we've had linear optimizers, and those are the types of things that we've typically reached for. And they've been around for a long time, and they're well established, and they work great, but they do have limitations. And so we definitely see DRL as kind of the next iteration, the next generation of these optimization approaches. And again, it seems to be pretty general purpose, which is really cool.
Where does your solution typically run? I mean, if we say cloud, edge, on a hyperscaler somewhere, or should it? I mean, do your customers, do they care? Do they care about DRL? Do they care about AI? Do they only care about, you give them a solution, and at certain levels, they don't care about what you call it?
Right. Well, and so there's a couple questions there. So where does it run? We're real cognizant. We live in this world of industrial. And so we're very cognizant that most of our customers are not comfortable with decisions having to go all the way up to the cloud and come back, because there's connectivity issues, there's latency. So the training typically has to be done in the cloud, because I will admit that the training of DRL is compute intensive, memory intensive. And so all of that has to be done in the cloud. But once you've trained it, the brain itself is just a plain Jane neural network. There's nothing exotic about it. It's just neural networks with weights. And so that can run on any commodity hardware. And so we run it as close as we can to the control system. Of course, we're control system experts, so we can hook it up to to the control system so that it can see, and in some cases actually take action based on its decisions. So we want to get it as close to, in the plant running on-prem and as close to the process as possible. As far as my customers caring, I've got customers that see it as a black box and it's proven. And so they're like, yeah, let's just use it. I don't really care what's happening. You guys are the experts. I've got other customers, though, that have robust data science teams that are involved in the development process. They're involved in the training and really want to own the system when we leave, which we always are happy and encourage that.
Okay. By the way, now you've kind of explained what autonomous is, at least share with you once. That as far as I'm concerned, only human beings are autonomous. Now, I think it's a great term, really. It's a great term. and we do even have, I think a couple of years ago when I was more into norming, I think that even within industrial space, there are specific terminology, global norms, IEEE, XYZ, I don't know which one. And they talk about several levels, grades of autonomous, I believe, right? Well, but in the end, you have decided to wake up, to show up here at the podcast, the same thing I did. But it doesn't matter. As I said, it's a great term. When we get into the negative space of, autonomous equipment,
yeah.
And maybe people who are probably not typically part of the podcast, but let's say more in general, consumers, and who are then scared because it almost implies that as if a machine could stand up and start doing things. And I think that's a question, or at least let's agree that is not possible. Whatever, still a human being, if your production line starts at 6 a.m, whatever, a human being needs to push a button. And from that time on, most certainly, right, I assume whatever you have kind of programmed into it with the help of deep reinforcement learning could be called autonomous, right?
Right. And I will say this, addressing kind of that concern about, autonomous head on, because I work in it every day, I'm actually more taken aback by how limited it can be in a lot of cases. So it's very limited in scope. Within that scope, it's probably the best optimization approach that I've ever seen. However, it is very limited in scope. So if I'm training, we did a project with an oil refinery for drawing diesel out of a distilling column, which is as much an art as it is a science, because you've got product above and below it. And so, you don't want to draw too much or draw too little. If I'm looking at that and I've designed an autonomous AI brain to be an expert at drawing out on-spec diesel, it can't do anything else. It can't run the plant. It can't write a poem. It can't do anything. All it's good at is that one very, very specific task. And so I get the concern about it and the fear around it. But the reality of it is while they're very capable of solving very specific problems, they're so limited in scope. And so the fears around Skynet and Terminator and things like that, probably we don't need to worry about that for a long time.
Don't worry. It's just me who points it out every now and then. So, yeah, sounds great. I only going to have a final more question looking in the future. But before that, 2-3 more things about your company. You mentioned looking at the global side, where you base, you originated in the United States, but for example, you're in Europe, you're in Asia, you're many different sites.
Yeah. So we started in Aurora, Ohio, which is just south of Cleveland, and that's the headquarters still. We've got, I think, 7 locations now in the United States. We've got 4 or 5 in APAC, and we've got 2 in Europe. That's Amsterdam and Dublin, Ireland. So those are our 2 in Europe. Our Asia headquarters is in Singapore, but then we've got Indonesia and Malaysia and Taiwan. So a couple other offices over there. So we've got a big global footprint at this point, which is really cool.
Very good. You mentioned 1,400, I believe, colleagues in roughly. Yep. You're looking for new colleagues. If so, what should they bring? Or question B, what is the typical kind of capabilities, so to say, that your colleagues, that they have maybe different from, other more general, maybe industrial automation companies? Yeah.
So we are always looking for new colleagues. And if you go to the RoviSys.com website, there's a link where you can apply for positions and things like that. I would say, what should they bring? Typically, the types of characteristics that we're looking for at RoviSys are we're really looking for generalists. If you come to RoviSys and you want to solve very, very specific niche problems, the problem with that is that we execute projects for customers and we don't always know what the next project's going to bring. That's part of the excitement. That's part of the fun. But if you say, I only want to solve this one specific problem, well, if we don't see that problem for the next 6 months to 2 years, that specific issue, then you're going to be pretty bored. So we're looking for generalists, people who want to solve a lot of different problems. We really look for people who have a pretty broad mindset around technology. If they're like, well, I'm a full stack developer and I only work in Java and I only want to use React or whatever, it's probably not going to work out. We really want people who have a broad mindset about a lot of different technologies, and you're going to have to learn constantly. The variety that we see in all of our customers is that there's a lot of heterogeneous systems, right? So we'll go into a place. I've never been in a factory where it's been just one type of system. You're going to have Rockwell, you're going to have Siemens, you're going to have, Honeywell, you're going to have all these different vendors there. And the customer's expecting us to deliver a solution that may touch all of those systems. And so we've got to be generalists. We've got to be able to reach into these systems. Some of them are very old, 20, 30 years old, get the data that we need, and then deliver a solution on top of that.
Okay, sounds great. Coming to a close, what is the status of autonomous AI in different parts of the world? In the United States, where you started, in China, Asia, in Europe, and how do you see then what we just talked about, autonomous AI going to change the industrial AI world over the next 5-10 years?
Yeah. So as far as the status right now, I would say that we're in the early days of adoption, but we're seeing incredible results. I was just at a trade show last week in San Francisco, and Shell presented publicly, so I can speak about it, presented publicly. I didn't even know they were looking into it, and they had a delivered autonomous AI solution built on deep reinforcement learning for startup and shutdown of one of their processes. So it's kind of happening in little pockets right now. As far as globally, it's a little harder for me to say, but definitely in the US, we're seeing some pockets, some adoption, and we're certainly leading the charge at RoviSys, talking about it. Where is it going to be in the next 5 to 10 years? I do see this as an inflection point, and I know that sounds like hyperbole, but I see the adoption of deep reinforcement learning in the industrial space as an inflection point. It's hard to deny, again, that the predictive stuff that we've seen with supervised learning is great, but the ability to actually make decisions and that ability to capture expertise into autonomous AI. I mean, I think those are it's exactly what the industry is looking for. They're trying to do more with less. And, you can get those squeeze a couple extra percentage performance out of existing well-optimized lines with this. And that's really what the industry is looking for. So I actually see once people really understand this, it's slowly but surely growing in the industry. Once people understand the capabilities of this, I think that it's going to really take off.
That's a great close, Bryan. Autonomous AI as a strategic inflection point to the industrial AI market. Looking forward to it. Those listeners that maybe you already mentioned the book, you can read about this as well. You mentioned by Kens Anderson. He works with you. I understand it's called Designing Autonomous AI. I did skim through it. I haven't been able to read it completely. Who is it targeting, the book? You went through it completely, I assume?
Yeah, well, he mentions in the intro kind of who he's targeting. Kent is very passionate. I work with him. I talk with him at least once a week, but he's got a mechanical engineering background. And so he's very passionate about engaging those engineers that are working on the line every day and wanted to provide an approach, a tool for them to be able to really capture that expertise that they have and leverage AI. So demystify the whole thing. But I mean, really, anyone can benefit from it. And I always recommend it to any of our customers that we're going in and doing an autonomous AI project as kind of a backgrounder on what we're going to be doing.
Perfect. Listeners that want to get in touch with you, your company, you suggested best way to get in contact with you is to go to the website, RoviSys, RoviSys.com/AI. And otherwise, if you, dear listeners, have any question, comment, as always, please send a short email to peter@ipod.de. Happy that you stayed with us so far. Looking forward to have you with us again next time. Bryan, thank you very much. Have a great day.
Thank you, Peter.